Video we'll be covering Chapter 2, Section 1, the basic set concepts. Okay. Sets are actually a collection of objects whose content can be clearly. Elements are the members of the set. Okay, so it's the object in a set. Okay. There's three different types of ways we can identify sets. We can describe them by using word descriptions. We can use a roster method, and we can use a set builder notation. Okay, let's go over the word descriptions. I can just describe the type of set we have. I could say B is the set of all members of the Beatles in 1963. That's the description. I could also say S is the set of states whose names begins with the letter A. Okay. If I wanted to use that in a rostered method, I would start with the set name, in this case B, just as I have here. And then in this particular case, I'm naming the individuals in the Beatles from 1963. Okay. S is the name of the set, and I'm going to name the states that begin with A: Alabama, Alaska, Arizona, and Arkansas. We could also use a set builder notation. Notice you still have the set name, which is the capital B here. The difference between these is that I'm naming the element. This is going to be our element X. This means where, like X, where X was a member of the Beatles in 1963. So the element X is describing the individual people who were in the Beatles in 1963. Okay. Set S is each member is called X, and X is the U.S. state whose name begins with the letter A. So these two are similar, but it also includes the format where you use the braces and the equal sign from the roster method. So it's a combination of basic. On this page, we're going to give our examples. We're going to ask for what the other two sets that are missing. Okay. So here we have P is equal to Washington, Adams, Jefferson, Madison, and Monroe. First thing I did here was identify the method that we're given. This is a roster method. Okay. So the word method would be set P, since that's the name here, is the set of the first 5 presidents of the United States. Okay. Now that I have the word and I have roster, the last one is set builder notation, where it's a combination of both of these. So set P is equal to the element X, where X is the first 5 presidents of the United States. For part 2, it says set M is a set of months beginning with the letter A. This is going to be a description, so this is called our word method. Okay. Then we're going to go ahead and list the roster method. We're going to list all the months that begin with the letter A. So I start with the set name, which is M, is equal to, don't forget your braces, April and August. Okay. Then we're going to go ahead and do the set builder, which is the combination of both of these. Start with the set name, M, equals, and then your braces. We're going to use the element X, and then we're going to describe it using words, where X is all the months beginning with A. Okay. Our third example is set O is equal to an element called X, where X is a positive odd number less than 10. This is going to be our set builder notation, so we're going to do it in words. Set is the set of all positive odd numbers less than 10. Okay. The roster method, we're just going to put O is equal to, and we're listing all of the positive odd numbers less than 10. The first odd number would be 1. then 3, 5, 7, and 9. We stop at 9. Now we're going to talk about an empty set. This is also called a null set. This set contains no elements. Okay, we represent that by an empty brace or a 0 with a line slashed through it. An example would be a set where the element X, given that X is a fawn that speaks. There are no fawns that speak, therefore it's an empty set. Another example would be a set where the element X, given X is a number greater than 10 but less than 4. You cannot have a number greater than 10 that is also less than 4. So this is going to be an empty set. Okay. Out of here, we're going to list which is the empty set. A, X, where X is a number less than 3 or greater than 5. Okay. B, X, where X is a number less than 3 and greater than 5. The difference between these two is the first one has the word or and the second one has the word and. This is going to become very, very important in the next few lessons. Okay. C is nothing, and D is the set of 0 with a slash through it. Let's talk about these. Okay. For part A, if you have a number less than 3 or greater than 5, okay, you can have a number less than 3. Let's say the example of a number less than 3 is 2, or we can have a number greater than 5. We can also say 6. So 2 or 6, and I'm using the word or, meaning it has to be one or the other. This is not an empty set. 2 or 6 are numbers that would fall within this set. For part B, it says a number less than 3 and greater than 5. Here the key word is and. So we're looking for a number that matches both less than 3 and. Part B is an empty set since no numbers match both criteria. C, the word nothing, that is not an empty set. And this one is deceiving because it looks like it's an empty set, but you have to go back to the original. You can have this or you can have that. This is a combination of both. So this is an incorrect answer. Okay, so the answer here would be B. A number can't be less than 3 and greater than 5 at the same time. Now we're going to be talking about notations. These are two specific symbols. This symbol indicates that an object is an element of a set. This means an element of. The one with the line across it means it's not an element of a set. Let's look at some examples. Okay. 8 is an element of this set. If you notice here, we have the numbers 1, 2, 3, 4, ... These 3 dots means that the pattern will continue all the way to 10. Since 8 is between the numbers 1 and 10, we can say that this is a second part says R is not an element of this set. Notice that there's no dots in this one between C and Z. So the only elements we have in this set are A, B, C, and Z. R is not among this element, so this is a true statement. Okay. For the next part, it says the set Monday is an element within this set, which says X is an element, which X is the day of the week. Okay. This is a false statement because anytime we have braces here, this description is saying that this is a set, not an element. Elements are just letters or numbers or words, not in the braces. So this is called a set, called Monday. It is not an element. If the braces were not here, this would be a true statement. So the thing that's making it false are having these braces. The next part is talking about natural numbers. So if we're looking here, we're saying that n is a set of numbers 1, 2, 3, 4, dot, dot, dot. That there is no ending number. This means that the pattern will continue all the way to infinity. We're going to express using the roster method. Set A is a set of natural numbers less than or equal to 3. Okay, so let's use a roster method. We're going to name the set, which is A, equals, and then we're going to list every element within that set. Okay, natural numbers, we know what the natural numbers are, 1, 2, 3, 4, all the way to infinity, but it has to be less than or equal to 3. So if it's equal to 3, we would include 3, 2, and 1. 1 and 2 because it is less than, 3 because it's equal to. We would not include 0 because 0 is not included as a natural number. States set B is the set of all natural numbers greater than 14. This is the word description, and we're going to continue using the roster form. Okay. B is the set's name, is equal to braces. Greater than 14 means it has to be more than 14. If I said I have more than $10 in my pockets, that doesn't mean that I have $10. It means that I have $10.01 or more. Okay, so in this case, it has to be greater than 14. So we're starting at 15, 16, 17. And because we go all the way to infinity and we cannot write that, we're okay to put the 3 dots. Example C, now we're using a O is equal to an element X, which X is an element of natural numbers and X is odd. Okay. So notice here we're using that X is an element of natural numbers. So that means X has to be a natural number and X has to be odd. So here is my roster format. I'm using the O is equal to, and I'm starting with my natural numbers, which is 1. And I'm going to list all of them that are odd. So 1, 3, 5, and then dot, dot, dot to continue the pattern. Example D. Using the set notation again, it's the element X, which X is an element of natural numbers, and X is less than 200. Notice on this one here, you do not have an equal sign underneath the inequality. So X does not equal 200. X has to be less than 200. So using our roster format, we're going to start with the first natural number that is less than 200. That starts with 1, then we go to 2, 3, dot, 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 all the way to the very last number that is less than 200, which is 199. For example, E, it says that the element X, which X is an element of natural numbers, and greater than 50, but less than or equal to 200. So the first element that I'm going to write has to be greater than 50. The very first element that's greater than 50, that's also a natural number, is 51. 52, 53, dot, dot, dot. The last element has to be equal to 200, so I can put 200 as the last element. The cardinal numbers is the distinct number of elements in a set. Okay, we're going to be using this symbol, and it's read as N of A. So here's our set A, and it has 3, 5, and 7 as the elements. So the cardinal number, so n of A, is going to be equal to 3 since there are 3 elements. B has 3, 3, 5, 5, 5, and a 7. Here it reads that the cardinal numbers, or n of B in this case, is equal to 3. Remember, even though there are lists of 1, 2, 3, 4, 5, 6 numbers, the cardinal number is a distinct element. These two elements are the same, so we count it only one time. 5 has 3 elements that are the same, but we only count it one time. So that's 1, 2, and the 7 would make a third original or distinct element. Let's go ahead and find some cardinal numbers of these sets. Okay. In set A, we have the elements 6, 10, 14, 15, and 16. None of these are repeating, so we're going to count 1, 2, 3, 4, 5. N of A would be equal to 5. For set B, we only have one element, so n of B would equal 1. For set C, we start at the number 9 and we end at the number 16. Use the formula last digit, which is 16, minus the first digit minus 1. So always take the first digit and subtract 1. This only works if the increment between the numbers is just 1. Okay. For set D, we can say n of D is equal to 0 because there are no elements in this set. The next part is talking about equivalent sets. It says set A is equivalent to set B only when they contain the same number of elements. So n of A must equal n of B. Let's look at set A. Set A is an element x, which x is a vowel. So let's look at all of our vowels. This is our set notation. This is our roster form. All our vowels is A, E, I, O, U. So that we have 1, 2, 3, 4, 5. Or n of A is equal to 5. Set B is element x, which x is an element of the natural numbers, and x is equal to or greater than 3 and less than or equal to 7. So if I'm doing my roster form, I'm going to start with 3 because it's equal to 3. And I'm going to end at the number 7, and it's going to be equal to 7. So I have 3, 4, 5, 6, and 7. This is my roster form. So let me go ahead and count. I have 1, 2, 3, 4, 5. So n of B is equal to 5. Since n of A is equal to n of B, sets A and B are equivalent. It does not mean that these have to have the same elements. Just as long as the number of elements in each set is the same. This next part is talking about the finite sets and infinite sets. Set is finite if the cardinal number is equal to 0 or is considered an empty set. It's also a finite if the n of A, or the cardinal number, is a natural number. A set whose cardinality is not 0 or a natural number, that is what we call an infinite set. Equality of sets, okay? Set A is equal to set B if it contains exactly the same elements, regardless of the order or the possible repetition of elements. Set A equals set B if the number of elements are the same and each element is the same. So notice on A we have W and on B we have W. For A, we have X and we have X on B. We have Y on A, Y on B, Z on A, and Z on B. So these two sets are equal. If they're equal, they are also equivalent because they have to have the exact same number of elements. So let's figure out if this is true or false. O, O, L, L, D, D. Are these sets equal? Yes. 4, 4, 5, 5. This contains the 0 with the slash through it, but remember we count this as an element. So in this case, we have 2 here, 2 elements here, and we have 3 elements here. So this is going to be false. Okay, this concludes our lecture notes for 2.1. Let me know if you have any questions.